Hello, you're most welcome once again to my channel. Today it is still your tutor Peter Ekaja, and I'm basically going to be taking you through the integrals of the form integral f prime of x divided by f of x with respect to x. Now in this tutorial, we are basically going to base on those integrals that will require us to apply the natural logarithm. We shall also look at the conditions under which we apply a natural logarithm. But before I get started, we need to recall one thing. From basic integration, we all remember that if I have an integral of x power n with respect to x, we are supposed to simply increase the power by 1 and divide by the new power, and then plus our arbitrary constant of integration. However, you need to know that this integral is only valid for all values of n except for n equals to -1. So this integral is not true for n equals to -1. Why? If n becomes -1, we can clearly see that this becomes x power -1 plus 1, which is 0. Definitely that will be 1. If it is x power 0, you'll get 1, but divided by -1 plus 1, which is 0. When you get 1 divided by 1, I mean 1 divided by 0, it is undefined. So you need to know that now we cannot proceed to take the value of n as -1. That means it is important for us to note right away that if I have integral of x power -1 dx, which is actually, by the way, as good as integral of 1 over x dx, then we cannot just say we're going to use the basic integration. Why? Because we are looking at our power of x being -1, and we said n cannot be -1. So we now need to know that when you integrate 1 over x or x power -1, we bring in some new concept, and then we call our result to be the natural logarithm or ln of x plus our constant of integration. So this is what is supposed to be taken seriously here, that we're not supposed to know. And from this, we're going to build up quite many questions and their solutions when we keep applying the same knowledge. Let's look at some examples. Okay, the very first example is here, and it says find integral of 2x divided by x squared plus 1 with respect to x. Now, one thing we need to realize and appreciate here is that the numerator is actually a derivative of the denominator, which actually conforms to our form that we highlighted in the heading. So how do we begin doing this? We are going to use the technique of change of variables and proceed as we are going to show in the next steps. So we shall decide to shall say let, for example, I've chosen a variable you can choose any other, to be x squared plus 1. After this, I am supposed to differentiate by looking for du dx, which is definitely going to be 2x. The next step after this, we are supposed to simply make dx the subject. And when you make dx the subject, you definitely get du out of 2x. Now, after making dx the subject, and we know now it's du out of 2x, we now make a commitment by simply saying that now our integral of 2x divided by x squared plus 1 dx is going to be integral of 2x divided by u, because we replaced x squared plus 1 with u. Dx has now become du out of 2x. And if you're very observant, you will realize that the 2x can cancel. So you remain with integral of 1 over u du. And this conforms to what I started with in my introduction, meaning it goes to a natural logarithm of u plus a constant. Now, we now make our conclusion and say, therefore, our integral of 2x divided by x squared plus 1 with respect to x is going to be equals to ln of u, but our u is x squared, as we started with, then plus our constant of integration. So this is how simply you would go about such a question. We can now look at example 2. Okay, so when you look at example 2, they're telling us to find the integral of 1 minus 2x divided by 3 plus x minus x squared with respect to x. So we shall follow the same procedure, change of variables. So in our solution, we shall say we let u equal to 3 plus x minus x squared. Then we get du dx. Du dx becomes definitely 1 minus 2x. Should you make dx the subject, dx becomes du out of 1 minus 2x. And from here, we go back and do the substitution by committing ourselves that integral of 1 minus 2x divided by 3 plus x minus x squared with respect to x is equals to integral of 1 minus 2x divided by u, because we called the whole of this denominator u from this step here. Then dx becomes du out of 1 minus 2x. So you realize again, 1 minus 2x can cancel out and we remain with our integral as 1 integral of 1 out of u with respect to u. And this means we shall get a natural logarithm of u plus a constant. But what is u? Our u is going to be 3, the way we started, plus x minus x squared plus our constant of integration. So we can make that conclusion that integral of 1 minus 2x divided by 3 plus x minus x squared with respect to x is actually equals to ln of 3 plus x minus x squared plus 1. As simple as that. Let's quickly look at now another form that has a trig function, and we see how to follow the same procedure. Okay, now this is an integral of tan x with respect to x. What we simply need to know here is that from trigonometry, tan x is as good as sine over cos. So we shall say integral of tan x with respect to x is actually equals to integral of sine x divided by cos x with respect to x. And then from here, we are going to let u to be, we shall let u to be cos of x. When you let u to be cos of x and you differentiate it, it means du dx will now become minus sine of x. And then when you make dx the subject, dx becomes du out of minus sine of x. Then from here we can commit ourselves by doing the substitution. So we can now say that integral of sine x, which we already now have out of cos x dx, is as good as integral of sine x divided by cos of x, which we call du, so I'm going to call it u. Dx is du out of negative sine x. And when you cancel out the sine x, you remain with a negative, which can be outside the integral sign. And then we have 1 out of u du. But you know, integral of 1 over u is a natural logarithm of u, or ln u. So I will say minus natural logarithm of u plus a constant. Then we do the substitution. So in our conclusion, we shall say integral of tan x is actually equal to minus ln of u, but our u is cos of x. Our u is cos of x, and then plus what? Plus a constant of integration. Now, someone can as well modify this answer if you bring the rules of logarithms. This expression we have can as well be written as ln of cos of x, but power negative 1 plus a constant. And cos power negative 1 is 1 over cos, which is sec x, and therefore the answer can as well be written as ln of sec x plus a what? Plus a constant. So it's as simple as this, but you can stop at this level depending on the requirements of the question, and if it requires you to go to this level, you can as well proceed. So that is our number 3, and I think I am going to end by giving you a few questions that you can now try out on your own to see whether you can as well catch up with these ideas. So let's go to the exercise now. Okay, so this is our simple exercise. I've only given 4 questions, but once you try them out, please ensure to also check with the quoted answers. I've given the answers against each question. And once you get these answers, it means you've really got what we've been talking about. I think, unless otherwise, I want to remind you that we also do one-on-one online tutoring. We help students from every country. And in case you need help, just get in touch with me using any of the following contacts. We have 0705110799, and then you can as well use 0784792369, and you can also book for time in case you need clarifications from me about whatever we're doing here. All these contacts are on WhatsApp, so we can always get in touch. Thank you, and see you in our next tutorial.